January 27, 1967. The wind cuts like a knife across the Kola Peninsula, the northernmost tip of the Soviet Union. Here deep within the Arctic Circle lies the frozen nerve ending of the Cold War, buried dozens of meters underground, encased in reinforced concrete. The air inside the air defense dome and center is thick and stagnant. It smells of stale tobacco, the ozone tang of high-voltage electronics. And something sharper than the Arctic frost outside, fear. Every pair of eyes is locked onto the glowing green sweep of the P-14 Ball King radar. Just seconds ago, an unidentified signal sliced into the edge of Soviet airspace like a ghost. It is not drifting like a reconnaissance balloon. It is not climbing slowly like a bomber. It is sprinting. With every sweep of the radar arm, the blip leaps across impossible distances. Senior Lieutenant Victor Kure feels his heart hammering against his throat. His finger hovers over the red alert button, sweat soaking through the back of his uniform. As a highly trained air defense commander, his brain is frantically running the calculations, but the conclusion seems absurd. Target speed Mach 3. Repeat, Mach 3. In 1967, that is not the speed of an airplane. That is the speed of a missile. It is the speed of a meteor. It is the speed of the apocalypse. Silence descends on the Kola and center, broken only by the hum of cooling fans. Have the Americans fired? As World War III started on this nondescript morning without warning, everyone braces for the shockwave, for the order from Moscow that signals the end of the world. But there is no explosion. There is no mushroom cloud. The blip simply traces an arrogant arc across the firmament right over the heads of the Soviet Union's most heavily defended airspace. It is not attacking. It is taking a stroll. This was the first time the Soviets truly felt the terrifying dominance. The terrifying dominance of the SR-71 Blackbird. This wasn't just an incursion, it was a humiliation of physics. According to the best Soviet aviation theories of the time, any object moving through the atmosphere at 3 times the speed of sound generates enough friction, heat to melt aluminum alloy. The shockwave should tear steel apart. To maintain such velocity, an aircraft's engines would have to guzzle fuel so ravenously that they would run dry in minutes. It should be a suicidal sprint, not a transcontinental cruise. Yet that ghost on the radar spent the next 40 minutes drawing a lazy circle along the Soviet border. As if it were in its own backyard. It did not slow down. It did not overheat or explode. It simply hovered at 80,000 feet of depths, where the air is so thin. It borders on a vacuum where the sky is no longer blue but a deep abyssal black. It was faster than a bullet and higher than the devil himself. To intercept this monster from the west, the Soviets unleashed their wildest creation, the MiG-25 Foxbat. To steel behemoths weighing 30 tons, each scrambled from a nearby airbase. With thunderous fury, this was the pride of Soviet aviation industry, the ultimate weapon built specifically to counter the Mach 3 threat. The best pilots were strapped onto massive T-Amansky R-15 engines. They were not flying a plane, they were riding a runaway rocket. But today's interception was destined to be a cruel farce. As the MiG-25s roared upward, clawing at the sky, to reach the intruder's altitude, the pilots realized with despair that their magnificent machines were hitting a wall. Warning lights flashed madly. Engine exhaust temperatures surged into the red zone. To even touch the altitude where the ghost resided, the MiGs had to sprint at their absolute limit. But it was like a sprinter trying to chase down a bullet train. The MiG-25 engines were screaming. The sheer volume of air and the heat of speed began to soften and stretch the turbine blades. If they stayed in this state for 1 minute longer, those massive engines would melt themselves into a pile of scrap metal. Meanwhile, 10,000 meters above them, the pilot of the SR-71 merely adjusted his stick. Through his pressure suit helmet, he looked out at a deep purple sky. The Soviet Union spread out like a map beneath his feet. He did not panic. He did not even need to perform many violent evasive maneuvers. He simply nudged the throttles forward. The target that the entire Soviet nation wished to destroy simply accelerated again, vanishing off the edge of the raid are screened with elegant T's, leaving only a silver contrail like a signature mocking the struggling pursuers below. This encounter left a massive psychological scar on Moscow, and it posed a riddle that kept top Soviet scientists awake at night. At the Central Aero Hydrodynamic Institute in Moscow, the brightest minds of the Soviet Union gathered around tables buried under blueprints. The room was filled with cigarette smoke and frustration. They could not understand it. According to their calculations, as speed increases, air resistance rises exponentially. For any air-breathing engine at Mach 3, the air entering the intake moves so fast it should blow out the flame. Like trying to light a match in a hurricane, the shockwaves generated inside the inlet should act like a wall, choking the engine, causing a loss of thrust, or even tearing the airframe apart. But this American plane, why did it fly better? The faster it went. Why did it seem to enter a mode of higher efficiency at speeds where Soviet jets had to dump fuel into afterburners just to survive? It defied common sense. It defied engineering. It defied the laws of God as they understood them. If this riddle was not solved, the Soviet skies would remain forever open to the Americans. To understand the root of this fear, we must dive into the heart of this black machine to uncover the most insane, brilliant, and counter-intuitive design in human aviation history: the Pratt & Whitney J58 variable cycle engine. This wasn't just an engine. It was a breathing, shape-shifted mechanical organism. In the 1960s, the term variable cycle did not really exist. But at Lockheed Skunk Works, the legendary designer, Kelly Johnson, had effectively created an impossible miracle. They did not try to build an engine that could fight the resistance of Mach 3. Instead, they decided to build an engine that could tame that violent force. Imagine this: when a plane sprints at 3,200 kilometers per hour, the air slamming into the front of the aircraft is not a gentle breeze. It is a solid superheated wall of destructive pressure. A normal turbojet engine needs to slow that air down before inhaling it. If you let supersonic airflow hit the spinning compressor blades directly, the blades would shatter instantly and the engine would explode like a grenade. So the secret of the Blackbird lay not in how it generated thrust, but in how it digested the air. If you look closely at massive engine inlets of the SR-71, you will see a cone shaped like a medieval lance. It is called the inlet's pike. This is the key to the puzzle. This is the throat of the beast. When the SR-70, once it's on the ground, this lance is retracted fully inward. It looks unremarkable, but when the Blackbird climbs into the heavens, breaks the sound barrier and begins its sprint toward Mach 3, the lance wakes up, controlled by a complex analog computer, a mechanical brain made entirely of gears and cams and linkages, because no digital computer of the time could survive the heat. This metal cone, weighing hundreds of pounds, moves forward. It extends and retracts inside the inlet, a movement of up to 26 inches. This is not a random action. It is an aerodynamic dance precise to the millimeter. Its function is to slice through shockwaves slamming into the plane. At 3 times the speed of sound, it traps that violent supersonic airflow and cleverly controls it within the throat of the inlet, using the shape of the shockwave itself to instantly slow air to subsonic speeds. It is like a judo master using the massive momentum of an opponent to subdue them. But slowing the air is not enough. Air that has been forcibly compressed and decelerated heats up to 400 degrees Celsius. For a normal engine, this is hellish hot enough to fatigue metal and vaporize lubricants. However, the J58 engine featured a design that nearly caused Soviet engineers to break down when they learned the truth. It bypassed the engine core. Between the engine caisson and the internal core, engineers designed a series of complex bypass tubes and bleed doors. Think of these as secret side entrances. When the speed hits Mach 3, the massive pressure at the front does not choke the machine. Instead, it forces these side doors open. That super-compressed, high-energy superheated air bypasses the fragile turbine blades entirely and is piped directly into the afterburner at the rear. In that moment, magic happens. The J-58 ceases to be a turbojet. It becomes a terrifying ramjet. In this mode, the spinning parts inside the engine, the fans, the compressors, the turbines, actually take a back seat. They provide only about 20% of the total thrust. The remaining 80% comes entirely from that air, which has been tamed by the lance, guided by the side doors, and detonated with fuel directly in the tailpipe. This explains why the Soviets saw the Blackbird flying more efficiently the faster it went. At Mach 3, it hardly needed to expend energy spinning. The front fans. It was moving forward by swallowing the shockwaves. It is like riding a bicycle where the wind, instead of blocking you, pushes you from behind. It was an illusion of perpetual motion, a perfect marriage of brute force and fluid dynamics. This is why the Soviet radar operators felt such despair seeing the target accelerate instead of slow down. For the SR-71, speed was life. Speed was the very reason for its existence. It had to fly fast to fly well, but to build a machine capable of withstanding such purgatorial conditions required solving a more fundamental and hornier problem: materials. When the SR-71 cruises at Mach 3, air friction heats the fuselage surface to over 300 degrees Celsius in the area around the engine. Exhaust reaches thousands of degrees. Traditional aviation aluminum would turn soft as chocolate at these temperatures. Stainless steel, while heat-resistant, was too heavy. The plane would never get off the ground. The only answer was titanium. Titanium alloy. Light as aluminum, strong as steel, resistant to heat. It was the only choice for the Blackbird. But here lies a massive irony. Dark enough to be written into the history of Cold War comedy, in the 1960s, the vast majority of the world's titanium ore was in the Soviet Union. Yes, you heard that right. The Americans wanted to build the ultimate spy plane to monitor the Soviet Union and humiliate its air defenses, but the flesh and bone required to build this plane had to come from Soviet soil. It was a perfect dilemma. Without Soviet titanium, the Blackbird was just a dead bird on a blueprint. So the Central Intelligence Agency orchestrated one of the most bizarre commercial operations in history. They did not send agents to steal, they sent businessmen in suits. The CIA registered a series of shell companies around the world posing as civilian metal importers. These companies approached Soviet foreign trade bureaus, claiming they needed titanium or to manufacture golf clubs, pizza ovens, or cheap bicycle frames. Officials in Moscow looked at these orders and rubbed their hands with glee. They thought they were fleecing the foolish Americans, trading piles of metal that seemed to have limited use were valuable foreign currency. They could never have imagined that ship after ship of titanium, or sent to third-party countries, was ultimately converging on Burbank, California, converging on the mysterious Skunk Works. Over 90% of the weight of every SR-71 Blackbird frame consists of titanium alloy. You could say the Soviets themselves provided the raw materials. For the sword that hung over their heads, when the Blackbird first displayed its unreachable silhouette over the Soviet periphery, the Soviets were essentially watching their own rocks fly. Every detail of this plane was filled with this contradictory tension. For example, on the ground, the Blackbird was a leaking bucket, if you were lucky enough to see an SR-71 on the tarmac. At an airbase in those days, you would notice drip pans placed onto the fuselage. The special JP-7 fuel would drip steadily onto the ground. Ground crews were used to it. This was not poor manufacturing, it was intentional. Titanium expands significantly when heated. To accommodate the inches of stretching the airframe would undergo during the thermal expansion of Mach 3, flight engineers had to leave the panel seams very loose. At ground temperature, these gaps were wide enough to stick a finger through, so fuel naturally seeped out. But once the Blackbird took off and accelerated the friction, heat made the airframe stretch and expand like a living thing. All the gaps would snap shut instantly, and the entire plane would become an impenetrable solid unit. It was like a mythical sword that only reveals its true form in the heat of the fiercest battle. But if we compare the J-58 engine to the heart of this beast, the blood flowing through its veins was another mystery that Soviet chemists could not crack. In conventional aviation, fuel needs to be flammable. But the Blackbird did not drink normal jet fuel. It drank a special liquid code named JP7. It was less of a fuel and more of a precision-engineered chemical reagent. It was an incredibly lazy, sluggish liquid. You could strike a match and throw it directly into a bucket of JP7 and the match would go out. It would extinguish as if you had thrown it into water. This extremely high flash point was necessary because when the SR-71 sprinted at Mach 3, the skin of the aircraft baked at hundreds of degrees. If they used normal fuel, the tanks would turn into massive flying bombs before the fuel even reached the engines. But this created a massive engineering headache. If you cannot even light it with a match, how do you ignite it at 80,000 feet? In a 3,000 km/h hurricane, Lockheed engineers used an even more extreme chemical triethyl bore, a NE, or TEB. This is a terrifying liquid that spontaneously combusting oxygen every time the Blackbird needed to start its engines or light the afterburners in mid-air. The pilot would hit us, which to inject a small dose of T. In that instant you would witness a visual spectacle unique in aviation history. If you stood at the end of the runway watching a Blackbird take off the moment the afterburners lit, the exhaust did not spit or inch tongues of fire. It spit a cloud of eerie, brilliant green flame. That is the color of burning boron. It was the Blackbird's signature green hell. To the Soviets, on the other side of the radar screen, that green flash was the signal that the demon had opened its eyes. This complex fuel system wasn't just for propulsion. Before the JP7 fuel entered the engine, it had to take a lap around the inside of the aircraft. It was pumped through pipes, along the leading edges of the wings, around the landing gear base, and even around the electronic equipment. Why? Because it was the coolant. In the inferno of Mach 3, no air conditioning system could survive. Those tens of tons of frigid fuel became the plane's only radiator. It absorbed the terrifying heat generated by air friction and the electronics, heating up to hundreds of degrees, turning into a high-energy hot oil before being sprayed into the engines to burn. In other words, the Blackbird was burning its own body heat. It was a closed-loop design of genius and madness. However, taming this machine was not as simple as pushing a few buttons. For the two men in the cockpit, strapped into full pressure space suits, every flight was a dance on the edge of a razor blade. They faced a specific term, a nightmare, that would wake any Blackbird pilot from a sound sleep, the unstart. Remember the inlet spike we mentioned, moving back and forth. Its position had to be precise to the millimeter. In this system, delicate as a Swiss watch, if the airflow suffered the slightest unforeseen disturbance, or if the computer was even a fraction of a second too slow, that shockwave, carefully controlled in the throat, would lose stability. It would be violently vomited out the front of the intake. This was not just an engine flame out. At Mach 3, one engine suddenly losing thrust and creating massive drag while the other was still pushing with full power created a yawing moment beyond imagination. In that split second, the pilot would feel like an invisible giant had taken a sledgehammer and smashed it against the side of the cockpit. The impact was so violent that the pilot's helmet would slam into the side glass, risking a broken neck. The plane would violently side slip and roll within seconds if the pilot's reaction was slow, or if they tried to fight the force too aggressively. A multi-million-dollar titanium bird would be torn to shreds by aerodynamic forces in mid-air. Yet, even facing such risks, the Americans repeated this game over the heads of the Soviets day after day. It was not just reconnaissance, it was psychological warfare. It was the highest level of humiliation. Records show that sometimes the Blackbird would intentionally deviate from its spike path to cut into the edge of Soviet or Allied airspace, simply to generate a sonic boom. Imagine being in Hanoi or Cairo or Murmansk when the SR-71 sliced through the sky. At 20,000 meters doing Mach 3, people on the ground could not hear the engine because the plane was outrunning its own sound. Only after it had passed would the double sonic boom be a boom roll over the ground like thunder from heaven. The sound was enough to shatter windows, set off car alarms, and make generals in meetings jump out of their skins. It was a silent declaration: I came, I saw, you could not stop me, and now I am gone. Back in front of the radar screens, the frustration of the Soviet air defense forces turned into a desperate rage. They calculated interception windows thousands of times. They fired thousands of SA to undes A-5 surface-to-air missiles. Every single time the result was the same. The missiles would scream into the sky. Radar operators watched the track of the missile and the track of the Blackbird merge on the screen. By conventional logic, it was a kill. But the Blackbird pilot would simply nudge the throttle or make a gentle turn. The missile's booster fuel would run out. Its fins would lose effectiveness in the thin air. Finally, it would detonate helplessly kilometers behind the Blackbird, turning into a harmless firework. Let us look at one heart-stopping chase. The early 1970s, the Middle East. This time, the Soviets were determined to settle the score. They deployed their most advanced radar-armed MiG-25 interceptors. In Egypt, waiting for the Blackbird to appear again. In that famous encounter, Israeli radar recorded one of the craziest moments in aviation history. An SR-71 on a reconnaissance run swaggered into the airspace over the Sinai Peninsula. Soviet commanders on the ground eyes, bloodshot, screamed orders. The MiG-25s took off from different angles. They were not chasing from behind, they were attempting a high-risk head-on interception, the only chance to hit a Blackbird. The MiG pilots pushed their throttles to full afterburner. Their airframes shuddered. Their missile seekers frantically searched for a heat source. On the radar, the blip representing the MiG-S and the blip representing the Blackbird were closing. At a relative speed of over 6,000 kilometers per hour, it was a death collision. The reaction time for both sides was measured in seconds. Inside the SR-71 cockpit alarm screamed. The radar warning receiver showed an enemy lock. If you were the pilot, what would you do? Turn left, turn right, dive to hide? No. For a Blackbird pilot, there is only one response. To all threats, and it is outrageously simple: push the throttle. Facing the trap carefully laid by the Soviets, the Blackbird pilot gently pushed the stick forward. The J-58 inlet's pikes retracted slightly, the bypass doors threw themselves wide open, and a torrent of fuel dumped into the afterburners. The airspeed indicator instantly swept past Mach 3, ticking toward Mach 3.2 and higher. In this moment, the SR-71 revealed its most terrifying aspect. It was not running away. It was accelerating to outrun the Grim Reaper. The Soviet pilots realized with despair that even in the perfect head-on position, their fire control computers could not calculate a firing solution. The target was moving too fast. The missile's logic could not keep up. As the MiG-25s clumsily tried to adjust their attitude, the Blackbird had already flashed over their heads. Like a black lightning bolt, the massive sonic boom rattled the canopies of the MiG-S. The Soviet pilots looked back and saw only that string of iconic shock diamonds, Mach diamonds, flickering deep in the stratosphere. They were the Blackbird's taillights. Its disdainful back. The MiG-S had to return to base defeated. Ground crews later found that due to the sustained forced high speed flight, the engines of that MiG were completely ruined and had to be scrapped, trading the total destruction of a fighter jet for the privilege of seeing the Blackbird's tail. That was the brutal rule of the Cold War sky. This sense of powerlessness eventually permeated the subconscious of Soviet engineers, the engineer we mentioned at the beginning who tried to explain everything with logic finally had to admit a fact. This was not just a technological gap, it was a gap in imagination. While the Soviets were using steel rivets and violence to fight the air, Lockheed's engineers had learned how to make the air their ally. They did not try to break the laws of physics. They found a back door in the laws of physics that no one else had noticed. And they walked right through it. The technological beatdown did not see its dramatic conclusion until long after the Cold War ended. In the early 1990s, the Soviet Union collapsed and the Iron Curtain fell. The world changed overnight. Former adversaries who once stared at each other's throats could finally sit at the same table and drink coffee. At a conference for American and Russian aerospace engineers, a white-haired Russian expert walked shakily toward Ben Rich, the designer of the SR-71, the successor to Kelly Johnson and the second leader of Skunk Works. There was no hostility in the Russian old man's eyes, only a curiosity that had tortured him for half a lifetime. Through a translator, he asked the question that had tormented them through countless freezing Siberian nights. Tell us, what magic did you use to solve the heat barrier? At Mach 3, we tried everything. Stainless steel was too heavy. Aluminum would melt. We knew we had to use titanium, but we could not manufacture titanium parts. That large in the welding process was a nightmare. How did you do it? Ben Rich looked at his former enemy, now his peer. He smiled slightly and revealed the secret kept for 30 years, the massive joke involving the CIA, shell companies, and the global supply chain. Actually, Ben Rich said titanium was not that hard to get. In fact, we have to thank you. The vast majority of the titanium used to build that plane was imported from the Soviet Union. At that moment, a deathly silence fell over the hall, followed by a complex, bitter laughter. The Russian engineers were stunned. They had sold their country's most precious strategic resource to the Americans at rock-bottom prices. And the Americans had turned those rocks into an undefendable sword that hung over their heads for 30 years. It was the greatest irony in history, a cracked, born in the closed era by the global supply chain. With the rapid development of satellite technology, spy satellites could transmit high-definition images in real time, without the risk of pilots being captured. The SR-71 Blackbird finally reached its curtain call in 1990. It was officially retired. Although it had a brief comeback in the mid-90s, its mission belonged to a crazy era. That had passed. It was too expensive, too complex, too independent. In this modern age of stealth drones, an electronic warfare machine like the Blackbird that relied on pure speed, pure altitude, and pure physical brute force aesthetic to survive has become an echo. We will never again see a plane that leaks fuel on the runway before takeoff, chases the sun after takeoff, and lands hot enough to burn your hand. On its final ferry flight, an SR-71 flew from Los Angeles to Washington, D.C. in just 64 minutes. Average speed 3,418 kilometers per hour. When it landed at the Smithsonian Museum, it set a record that remains unbroken to this day and perhaps will never be broken. Today, on the ruins of the Kola Peninsula, that air defense bunker is likely buried in snow. Those radar screens that once terrified Lieutenant Victor long rusted away. Across the ocean in a museum, the Blackbird rests quietly on the ground like a sleeping beast. Tourists walk past it marveling at its sci-fi shape, but few can truly understand what kind of heart-stopping history is sealed beneath the black titanium skin. It is not just about American technology, it is about Soviet pressure. It is the furthest step human engineering has ever taken, driven by the fear and paranoia of two superpowers. It is the tombstone of that era and its monument. When we look up at the sky, now planes are quieter, smarter, more hidden. But at the edge of the stratosphere, in that deep purple silence, the unique pulse jet roar of the J-58 engine seems to still echo, reminding us humanity once had a pair of true wings that could outrun the Earth's rotation and chase back lost time. The SR-71 Blackbird, a testament to what happens when you mix genius engineering with absolute paranoia. If this deep dive into the Cold War's wildest ghost story blew your mind, make sure to ignite that like button and subscribe for more tales of titanium and terror. I am your history co-pilot signing off from the edge of space.